Hey guys, today we're going over how to make a very simple CAD part on PTC Creo. PTC Creo is a super powerful CAD software used by engineers and designers all over the world. So if you ever wanted to get started with 3D modeling but felt intimidated, this is the video for you. So as I mentioned, we're going to design a super simple part step by step that will give you a solid foundation to 3D modeling through Creo. So what exactly are we making today? We're going to design a simple rectangular block with a hole through it. Think of it like a very basic bracket or a spacer. It's fundamental, but teaches you some of the most important concepts in Creo, such as sketching, extruding, and creating holes, as well as adding features to your parts. We'll introduce you to creating features, understanding the model tree, and navigating the interface of Creo. Alright, so let's jump into the video. So first, we're going to start by creating a new part. We can just select this on the top left under the Home tab. In the Type box, make sure Part is selected and Solid is selected. And for the name, let's just call it Part 1, and then simply hit OK. You'll now see a blank workspace with our default datum planes, the front, the top, and the right. These are your reference points in 3D space. So our first step is to create a 2D sketch that will then turn into a 3D shape. We'll start by sketching our rectangle on the top plane. This is going to be our base. You also want to make sure that you are using the correct units. So go to the files, then check your file properties to make sure that you are sketching and creating these 3D geometries in the units that you want to make these parts in, so that, say for example, if you're then creating an assembly and you have different parts, make sure that all the parts are in the same units and that they will then assemble very nicely. So here we can see that the part is in inches, so this is correct. This is what I want to model in. So we can go ahead and close the model properties now. Now select the top datum plane in the domain, and you can simply right click and click on the sketch icon that pops up. You also want to make sure you're oriented in the correct view, so this is the top view. You can adjust this on the ribbon right below your panel, and you can just adjust your orientation that you want your views to be in for your sketches. So here we're seeing the top plane head on. You want to go to the sketching tab and select the rectangle tool. You can choose to select the center rectangle tool, but just so that I can show you some of the features, I'm just going to select the basic rectangle tool so that we can see how the constraints work and play around with those a little bit. But the center rectangle usually is easier as it creates the rectangle symmetrically around the origin. So click once wherever you want that corner to be, and then drag that rectangle out, and then click again. Next, we can create center lines. This will make it easier when we are playing around with the constraints and different features that we will be using. Next is a pretty clever way to constrain a horizontal or vertical line, say for example in this case in a rectangle, is by sketching a point on that intersection between the center line and the horizontal, or the center line and the vertical lines on the rectangle, and then using that midpoint constraint to make sure that that line midpoint is that point that you created. So now that we have our perfectly symmetrical vertical and horizontal lines on the rectangle, we can now go ahead and dimension the vertical and horizontal components. In this case, I'm choosing 150 and 80. Next, we can click the green check mark or the OK button to exit the sketch mode. So now that we have our 2D rectangle, let's give it some depth and make it a 3D solid using the extrude feature. So with the sketch selected, click on the extrude tool in the ribbon, or you can simply right click the sketch that you want to extrude, and you'll see a preview of your block forming and a little arrow indicating the direction of extrusion. In the dashboard that appears, you can change the depth, and here we're just going to make it 50. So type 50 and hit enter. You can also change the direction if you need to, but for now the default is fine. So click the green check mark to complete the extrusion. And just like that, you've created your first 3D solid in Creo. Pretty cool, right? Now let's actually create the bracket shape. So we're going to want to cut the sides of the rectangle and extrude using extrude cut. So the process is going to be very similar to what we just did with a rectangle, but this time the rectangle creation is going to be much simpler because the points are going to simply snap onto the already created rectangular points that we can see in this top view head on. So create a rectangle on the far left side of your rectangular base, 3D geometry, top view, and then type in your dimension. In this case, it's going to be 25 inches. And then hit enter. Make sure you have a center line because we're going to mirror this. You can simply hit the extrude on the ribbon tab. Here we're going to select remove material and we're going to change the direction. We're also going to specify the depth to be 20. So we don't want the extrusion cut to be through everything. Next, we're going to use the mirror plane tool. And so you want to select that cut, and then in the mirror plane, you want to select the plane that you want to mirror the feature about. So in this case, we're going to mirror the cut about the right plane, and so this is going to duplicate. Don't forget to rename your sketches and your features so that you can keep track of exactly what you're doing, so if someone else is checking your work, or simply if you just want to go back and understand your work after not using it for a long time or not seeing it for a long time, you can very easily trace back how exactly you built your part. And if you need to adjust anything, you can easily do so. This also carries over if someone else is working on your part. If you're working on a team, they can very easily trace what exactly you did and what parameters they might need to adjust if they need to adjust anything. Now let's add a hole through a bracket. There are a couple ways to do this, but here I just want to show you how to use the hole tool. So we want to select the hole feature under the engineering section in the modeling tab. Again, we want to adjust the view so that we can see this head on and work from the top view. Next, we're going to specify what type of hole we are going to create. So the type is going to be standard, clearance, counterbore, and then here we can change the size of the hole. So I just kept it as UNC, and then I'm doing a 3/4. In this process, you should also adjust the depth. I don't do this right now, I do it later, but while you're at it, you should also adjust the depth. In this case, I just do through all. Then you want to specify your placement, where your hole will be placed. So under placement, select that top face of the bracket. And then in offset references, the type of offset will be linear. So select that vertical and horizontal lines on that top face of your bracket, and then specify the dimensions. Next, we can move on to the shape of the hole. So here I'm choosing a diameter of 50 inches. The depth is going to be 10 inches, and then the inner diameter is going to be 40 inches. So here we can see the hole is created. Now we have a hole on our bracket. So now you can click the green check mark to exit sketch mode. And now we have a fully completed bracket. And again, just make sure you rename all of your features on that tree. And something I like to do, you don't have to do this, but something I like to do just so that the work looks cleaner, I like to hide all of the planes and any datums or coordinate systems we don't really need or that are kind of in the way, and then any other features that we don't really need at the moment. Of course, when you're working with a team or you're transferring knowledge or information, you want to make sure you show everything that you should show so that everyone can see any important information about the part. But since I'm just showing you this part right here, there really is no need. And then here you can play around with the views. I like shading with edges, but you can change it to be wireframe, no hidden, shading with reflection, any type of view that you might prefer. But I'm a fan of shading with edges. So next I'm going to show you how to use the chamfer and round features. So rounds are often called fillets for internal corners, and both chamfer and rounds are features used to modify sharp 90-degree edges on a part. They're crucial for both functional and aesthetic reasons. So a round or a fillet replaces a sharp corner with a smooth curved surface defined by a radius, and the purpose is that it reduces stress concentration points on mechanical parts and makes handling safer and generally improves aesthetics. Note that in Creo, the command is typically called round for external edges and fillet for internal ones, but the tool often handles both. The chamfer feature replaces a sharp corner with a flat angled surface, and the purpose is that it removes sharp edges, usually for safety, and simplifies assembly by guiding mating parts like pins or screws, and it's just easier and cheaper to machine than a perfect round. And it's often specified as a distance by an angle, like for example, 1 inch times a 45-degree angle. So first we're going to add some chamfers to the part. So here we're going to select just these 4 edges on the side of the bracket. You can adjust how intensely you want that chamfer to be as I described previously. And here I'm choosing 1, 10, or 5. I'm just choosing 5, something in the middle. so that it's not as intense, but not as subtle as well. We want something that we can definitely notice. And then again, rename your chamfer to be just a side chamfer. Make sure that your chamfers, you're also keeping track of your chamfers and your rounds. So if you ever need to go back and re-edit those, you can easily do so. Next, we're gonna implement the rounds on the part. So here we're just implementing these on the horizontal sides, whereas the chamfer, we implemented it on the vertical. And then we can do a similar sort of exercise. We can see how that would look with a round of 10, 1, and 5. And so here I'm again just choosing 5 so that all of our rounds and chamfers line up smoothly. And we have a much nicer looking part and safer and easier to machine part. So you want to define the radius of your round. So notice how the edges are now smooth curves, and if you need a different size, you could create a new set within the same feature and apply different radius to a different group of edges. Same goes with the chamfer. Next, I'm going to show you how the shell feature works. So I'm going to apply the shell feature to the bottom of the base so that we create essentially a bracket that looks a little bit like a Lego. The shell feature also works pretty similarly to the chamfer and the round. The logic carries over as well. Select the shell feature and then select the face that you want to shell. This will remove the surfaces and keep the surfaces to create a perimeter around any of the intersecting geometry that you might have. Such as that hole we created, you're going to have a perimeter around that with a certain thickness. So with shell, you can very easily remove any volume that might be tricky to remove manually or more robustly. And so it very easily and very simply removes this geometry from, say for example, this bracket, so that you're left with a perimeter, and then you can adjust the thickness. So on the top left, as I mentioned, you can adjust the thickness. You can make it really thin to be like 1, or you can make it really thick. Sometimes if you make it too thick, it'll be counterintuitive and it'll cover the whole part again. So you want to make sure that the thickness and the design is appropriate for the part's applications in environments. So as we can see here, we have a fully modeled part, and we just want to make sure we hide those last final annoying pieces that are in the way. So now that we have our simple part, let's talk about a concept that will become absolutely critical as your designs get bigger and more complex. It's one of my favorite tools, and it's the simplified representation, or the SimpRep tool. So what even is a simplified representation? Imagine you have an assembly with hundreds or even thousands of unique components like an entire car engine. If your computer tried to display every single detail, every round, every chamfer, every bolt thread, it would slow down to a crawl. So a simplified representation is essentially a view setting that tells Creo what details to load and display. So by default, you're always viewing the master representation. This loads every feature, every detail, and every single piece of geometry. A SimpRep allows you to create lighter versions of the model or assembly, or different versions, which your computer can handle much faster, especially when panning, zooming, or rotating. This is also extremely helpful when you're designing more conceptual parts or just have different ideas for designing the part. You don't have to completely alter the part, or you don't even have to create a new part. You can just create a new SimpRep and model it using this tool. So to pull up SimpRep and that view manager, you can access it through the ribbon. It will be the icon with the camera. So if you click on that, your view manager comes up and you can click on the SimpRep tab. So when we're looking at the different options, when you click on the representation control, you will see options like the master. This is the current default where everything is loaded. The default, which is also the same as the master, and in this case, it's called the automatic rep. And then next, we're going to want to create new versions of this part. So just for a quick example, within SimpRep, you can simply select new, create a new version. We can just call this version 2. And then here, we're simply going to want to select exclude. So for example, we want to exclude the rounds or the chamfers. Here, we're just going to exclude the rounds. So select those rounds. Select exclude, and then select done. This will remove the rounds, and this will give you a version of the bracket that has no rounds. So if we go back to master rep, we can see those rounds are there, but in version 2, they're removed. And if you're not sure what version is currently shown, you can simply see this on the model tree on the left, and it says version 2. And finally, don't forget to save your part. And we can simply do this by clicking on File and Save As. And there's different saving options. So under File Type, as we can see here, we can pull this up. The default is a part file or a .prt file. This is the native format for a single component in a software like PTC Creo, and sometimes in an X. And it essentially stores the entire design history, parametric features, and detailed metadata. Then a step file or a .stp file, or simply .step file. This is essentially the gold standard for sharing 3D solid models between different CAD systems, so from Creo to SolidWorks or any type of different software that other people might be using. And .stl file, this is usually the universal format for 3D printing and just rapid prototyping. Then a drawing file or a .dwg file. This is the native file format for any type of AutoCAD. So while it supports some 3D data, it's mainly used as the industry standard for 2D drafting, schematics, floor plans, and technical drawings. So this is great for transmitting information to manufacturing or in actually manufacture your part and create it in real life. Next, the ECAD files. This is the electronic computer aided design. This refers to specialized software and file formats used for designing electronic systems, specifically printed circuit boards or PCBs, and integrated circuits. So keep in mind that these are distinct from MCAD or mechanical CAD, which handles the physical enclosure. So for our case, this is not really relevant right now, but it's important for you to understand this basic distinction between an ECAD and an MCAD file. And finally, a shrink wrap is a lightweight, simplified part file created from a complex assembly in PTC Creo, and similar software features exist in others. So shrink wrap captures the exterior shape of an entire assembly using a collection of surfaces or a faceted solid, but it excludes all internal details, design history, and parametric features. The benefit is that it significantly reduces file size, often by over 90%, dramatically improving performance when working with large assemblies, and it allows you to share an accurate external model with, say, customers, suppliers, or other design teams for fit form studies without really disclosing the complex internal geometry or any kind of proprietary design details. So these are the main kind of files that you really need to concern yourself with when you're first starting, as these are the most commonly used. But for saving a part file simple like this for beginners, you should just save as a .prt or a part file within Creo. And now that your part is saved as a .prt file, you now have a completed PTC Creo part. Congratulations! I hope you learned a few things in this video. Thank you for watching, and I'll see you in the next one.